Right, so I just want to have a look at one particular question. Trying to find it, which one it was. Actually, can you read read out the question that we were just looking at?
3 and then in brackets x minus 6 plus 7x equals 5 in brackets 2x minus 1.
Okay, so everyone, pens down. You've just done face masks, you can give me a moment to talk to you. What this statement, if I asked you to say that in language, speaking it, what would you tell me? The same voice. Come on, other people. Go on, what would you say?
I think of a number and then subtract 6 by it, then multiply the result by 3, and then add that result by 7, which is the same number doubled, subtract 1 times multiply that result by 5.
Right, a bit, yeah. You get the right idea, but a bit unclear. Anyone want to have a clearer go?
Mine wasn't like that, but I was going to say 3 lots of x are subtracted by 6.
See, that's not true, is it?
Oh, what did that be?
No.
That's not true. 3 lots of x subtract 6.
Oh,
not.
x subtracted by 3 lots.
It's 3 lots of x minus 6.
Oh.
Wait, 3 multiplied by x minus 6 multiplied by 3 plus 7 and then the unknown number, which equals...
So I want it in a bit like less just abstract mathematical talk and more normal English talk. Go for it.
Maybe just that this side is equal to this side.
Okay, so we've got one side is equal to another side. Could we go a bit more? What are you going to say?
Oh, no,
No? One go?
3 lots of x subtract 6.
Can we do it?
Plus
Get back to
7
the think of a number.
multiplied
So
by that number.
let's go back to I think of a number. Johnny thinks of a number.
Okay, Johnny thinks of a number.
He subtracts 6 from that number.
No, but isn't x?
Okay, yeah.
Johnny thinks of a number, he subtracts 6 from that number.
Then times the result.
Then he times the result by 3.
And then adds it by 7 times the original number.
So I would say he multiplies that result by 3 and then he adds on another 7 lots of that number. And he gets an answer. Now, I would say in this situation we would say he also takes the same number, doubles it, subtracts 1, then multiplies the result by 5, and what happens is he gets the same answer. So that's when we've got the equals on either side. This is what the equals means. The result here is the same as the result here. So what we are looking for, what's the end result, is I am looking for a number where if I apply this stuff to it on the left, I get the same result as if I do something completely different what's on the right. But I should end up with the same result. Does that make sense? That's what we're doing here. We're trying to find that number. So you are coming up with what that number is. So you are now finding the number where each side is equal. Now why is that appropriate? Well, in an applied situation, you might be looking for a particular speed where 2 boats are going to hit the same point at the same time. So you want to, air traffic controllers, why don't planes meet? Because they need to make sure they don't find that number where both those planes are in the air at the same time, at the same point, and therefore people are sharing seats, and they shouldn't be, So it is a useful thing to have. And if we were to, I think you said graphing it, where one side is equal to another, we would see what in the graphs? Not the same curve. These would be different, but for one value of x, the graphs would give the same value of y, and the graphs would meet. They will cross. They may they will only cross at one point, because this line is different to this line. They will meet at one point. Do all lines meet and cross?
No.
Not necessarily. So if we go through this one, how do we solve for x? Maths, keep you awake.
Solve for
How do we
x.
solve for
Yeah. Start me off.
on that side?
Whichever one you want.
You have to expand.
Okay, got it.
So 3 times x would be 3x minus.
Oh, I blanked.
18.
18. And then I've got plus 7x. And on this side,
10x minus 5.
okay.
Madison has a really passive voice.
Jen, carry me on.
Oh. Then you do like collect the like term.
Yeah.
So it would be 3 plus 7, which is 10x
It took way too
minus 18 equals to
You're
10x minus 5.
Okay.
You're kidding.
What happens next?
You have to get rid of one of the x's.
Okay.
So personally, since they're positive, you would minus them.
So I'm gonna
you
minus-
do minus 10
Minus 10x's.
and minus 10x. So you'll be left with x subtract 18 equals
No, I won't. I've got 10x's, subtract 10x's. I'm left with
0.
no x's, so I've only got 18 there, and then I've got on here.
5.
But that does not.
No,
Okay.
that's not right. That's not right. Where's
No,
the
you're right. Minus 18 does not equal minus 5. Have I done anything wrong mathematically? What?
We could have added it.
You could.
See, this is the issue. This is why I wanted to go through. What's the end result? Why are we doing
You
it?
don't-
Unless you really know what you're looking for, you're not going to be happy when you get a result like this. Whereas I'm perfectly happy. I knew what was going to happen beforehand because I'm thinking of graphs. All right. This line, I was like, I don't need to go any further, and I'll tell you why in a minute. But we've got this result. Minus 18 is minus 5. That can't be true. It's not true. It never will be true.
Don't you bring the 10x to the other side?
No, no, no,
Oh,
no.
When you-
No, we've done nothing wrong.
Oh.
I've subtracted 10x from both
It's supposed to
sides.
look like that, just that we've never seen something like that, so we would.
So what we're trying to do is I want you to be able to interpret that result. Right? Rather than get worried about it, rather than think you've done something wrong, you've got to have the ability to interpret that result. So is there anyone apart from Samira, who we've already talked about it, that can interpret what that actually means? And think about what I was talking about at the very beginning. Go on, give it a go.
I was going to say that. Never mind.
Never mind. Okay.
I guess. Okay. I was gonna maybe 1 over 18, 1 over 5. I mean 1 over negative 18. No.
Well, what you're still trying to do is there's nothing more to be done.
Oh, it's
There's
5.
no more maths to be done. I have to interpret my result.
What do you mean by
So it basically means that there's two, what's it called? Whatever the code, I forgot what the code. They don't equal, so like if you look at it on a graph, the lines will never meet, so they're like parallel or something. So
Yeah.
there's no solution.
That's it. There is no solution. That's all we have to be able to say. What does no solution mean? There is no value of x where those two things will be equal. It isn't. Right? Do you remember I said about the graphs, the lines? Right? These two graphs will give you, well, if I look at this bit here, right? 10x minus 18, do you recognise that as a straight line function, yeah? Linear function? Remember doing y equals mx plus c in year 9? Yeah? That's a straight line. 10x minus 5 is another straight line. Do you remember the mx plus c? M is the, remember, the gradient. Gradient means how, what about the line? What's the gradient? How steep the line is. Therefore, if two lines have the same gradient, the two lines are Not equal. Parallel. And do two parallel lines ever meet?
No.
No. No.
I'm not gonna get into
Well,
it.
they
I'm not gonna
can
get
start
into it.
to.
Not in our plane. No.
Parallel have to
That's
know.
intersection.
I know.
Right, so what we are saying, and this is why I thought this was important to talk about, is these two original, these two original equations, no, sorry, not two equations, this equation, these two, what we call expressions, right, these expressions, they will never be equal. So this can never be true. So if we end up with a situation, right, obviously this is not true, so I put a line through my equal sign. You may have seen that before. Not equal to. Therefore, up here, these two will never be the same. Right? On another note, there was another one we looked at. Did you have a question, sir?
Yes.
Yeah.
When you said the I word, what was it? Interpretate. What?
The interpret. Interpret means look at it and decide what it's telling you.
So I can like write notes on my page in a test to be like expressions not equal. Like, well, what?
You write what you like, but
I mean, like, is that a part of the answer?
no. So here, for instance, if you were being asked to, if in a test I said to you, solve that, interpret your result, then I would be expecting you to write, there is no solution.
Oh, so even if you just said solve it, would we still write no solution?
Well, if I gave you a question and said solve it, well, I might do it as a test, a mini quiz or something, but in your IGCSEs, you're not likely to get one like this, to be honest.
Okay.
You know, they wouldn't chuck that in. If you see, if it ever says interpret your result, you know you've got something else to think about, right? Lots of times you'll get interpret your result, draw a graph, interpret what it tells you. Yeah, that kind of thing. Now I just wanted to go through this one. There was one that ended up as, I think, 6x minus 12 equals 6x minus 12 after you've done some expanding and simplifying and that kind of thing. Right, again, I want you to be able to interpret that result. So what does that tell us? We are trying to find x. What do you end up with? In this case, you would end up with 0 equals 0. Right? Is that true? Yes. Alright, you'd have done that by adding 12 to both sides, gets rid of it, subtracting 6x from both sides, gets rid of it, so you end up with 0 equals 0. Now that's fine, isn't it? Okay, but if I had to interpret the result, what do we say? What will x equal? Does x equal 0 then?
Yes.
Can x equal 0?
Yeah.
Is that the answer then? X
No.
equals 0. Okay. Do you see how, if I go back to this, what does this mean? I'm saying this side has to equal this side. So I'm asking for what value of x can I pick where the left-hand side will equal the right-hand side. I'm asking for what possible values of x. Now sometimes, and a lot of the times, there is only one value of x that will work. Alright? Before, we found that there were no values of x that will work. When we go into quadratics and things, there will normally be two values that will work. Because a curve, it goes back up again. So if you've got a line crossing a curve, it crosses twice, potentially. In this case, though, what do you notice about the left-hand side and the right-hand side?
They're the same.
They're the same. So if I were to draw, do you remember the mx plus c? If I were to draw those two lines, it would be something like that. That'd be one line. Where would I draw the second line?
Intercepting it.
Intercepting it.
Like,
The exact same line.
On top of it, it's exactly the same line, isn't it?
Oh. Oh yeah, because
All right. So, what values of x can I pick where one will equal the other?
Any value.
Any value of x, because they're exactly the same equation. So I can't, my full solution is not x equals 0. That is one possible solution. But what about x equals 1? If I put that in there, 6 minus 12 is equal to 6. It just makes it, whatever value of x I pick, it's going to be equal. So how would we write x can be any number? Well, I've got a nice mathematical way of doing that.
Maybe x equals infinite.
Okay, so this x equals infinity. Well, you can't equal infinity. Because an equal sign, I know you know,
Equals infinite?
equal sign means it is equal to that. They have the same value. What value does infinity have?
No value.
Right, infinity is a concept, not a value. So we can say something goes on infinitely,
Oh, I didn't mean
but
that.
it doesn't have a value. So I know what you mean. So it's this equal sign that you are again misusing, I guess, at this point. So we don't write equals infinity.
You can write x equals x.
Meg,
I'm sorry.
x equals x. Well, that doesn't tell me what x equals. It just tells me what that x equals x, which is fine. But what am I allowed to use for x? That's what I need to say. Because if I say x equals 1, I'm allowed to use 1. Tell us, what do we say?
X is the element of any real number.
Okay. X is an element of, and then we have a fancy R, like that.
Oh, didn't you draw that on the board like yesterday?
Now, what this means is, if I was to write that out in full, this E means is an element of, okay? I'll do it in simpler language in a minute. And the R means the set of real numbers. Okay? So we're talking number sets. So you must know about some number sets.
3, 6, 9.
Integers,
Oh.
rational numbers.
No.
Well, decimals would fall within another set, real numbers. Numbers that can be at fractions are rational numbers. Numbers that can't be expressed as a fraction, we talked about them, they're called irrational. It's on the board over there. Okay, real numbers are basically all numbers apart, we've already taught this, apart from real numbers, apart from, every number is real apart from those that aren't, and they're called
Irrational.
Irreal.
imaginary. Remember we talked about that?
Imagination.
Imaginary numbers. So we're basically, by saying this, we're saying x, if I just said that, that's how I write it. The actual way of saying it is x is an element of the set of real numbers. Is an element of just means x is in the group of real numbers. Okay? Make sense?
Yeah.
So, really want you to think about when you're solving these equations, what is it that you're actually finding? Right? If you never even think that way, you'll never really truly grasp what you're trying to find out. And then the harder stuff will remain hard. Yeah?
Using letters, if you scroll back up, could you write something like that? Or because there is no x, you can't write anything.
Yeah, so x, there is no real solution, there's no solution. X doesn't belong to anything, I'll just have to write, there's no solution. Yeah. I could write, I guess, put a line through there and just say x is not equal, cannot equal to. But actually, if I did do that, and then I solved it, I would then write x can be any number, can't I? Because I can pick any value for x, and they won't be equal. So, got to be careful how you use it. Yeah. Right. We had it suggested that we wanted to go through one particular one.
Oh my goodness.
So,
Oh.
alright, it was suggested. So let's see what you say. So we've got 2x minus 1 over 3 minus 5x minus 6 over 6 equals minus 2. Right. So, how do we go about doing it? So we've got brackets around here because we've got to subtract. But what do we do? I've got a way, I've got a couple of ways.
Why don't take out the brackets?
What did you say?
Just check both.
How do we do it?
Oh.
What am I trying to find, by the way? For what purpose? I'm trying to find the value of x that
Equals this.
makes this fraction subtract that fraction equal to minus 2. That's what I'm looking to try and find. So I want to find that one value. Okay? Do you think it'll be one value, no values, lots of values? Probably one. Go on, what would we do?
Maybe, so if I go backwards, so maybe it's -2 plus bracket 5x equals 6.
Well, the thing about that is you can do that. Do I want to?
No.
Why?
Oh, you could do a different way.
Don't you want the x's all on one side?
Yeah, you
Do you want to collect the like terms, yeah?
You could do -2
How do I
plus 6.
well, how do I subtract fractions?
You add them, so -6. -2 plus.
No, you can make it -2
over
When you do fractions, think just fractions, what do you have to do when you subtract or add?
You can make the bottom line the same.
You have to make the denominator the same value. So my denominator is 3 and 6, so what do I need to do? Yeah,
Times it by 2.
times it by 2. So this one times 2, top and bottom. It doesn't change anything, it just gives me an equivalent fraction. So I end up with 2 times 2x minus 1 over 6 minus 5x minus 6 over 6.
Why is that one in a bracket and another number?
Because it's a subtract, and it's a subtract with a negative, so that means we're going to have to subtract a negative at one point, so we're going to have to add. I want to subtract all of this. I don't want it to be subtract 5x then subtract 6. Alright. Now there's one step, girls over here, maybe you didn't do it this way, so I want to introduce you to maybe a new way of doing this. Right, fractions. I could collect it all together, but what I'm actually going to do is I'm going to change -2 into -12 over 6. Do you know why I've done that?
So it's an equivalent.
So I've got, are you happy that -2 is the same as -12 over 6?
Yeah.
Yeah? Why did I choose to do it as something over 6?
So all the denominators are the same?
So all the denominators are the same. Now, the reason why I've done that is because now I can make this statement. Well, if that over 6 minus that over 6 is equal to that over 6, I can actually just ignore the fact that 6's exist. And I can just say that all the tops have to be the same. So I can do 2 times 2x minus 1 minus 5x minus 6 is equal to -12.
And your final answer, would you add this?
No, I'm done. All I'm saying is I just want to know that the tops are equal. That's all that matters. Now the denominators are all the same, the numerators have to be the same.
Wait,
so I can
you
kind of
won't
ignore
work it
it.
out anymore?
Oh no, I now have to
Oh,
solve
right.
for x, but I don't need to do anything with the 6, it's gone.
So how do you get back to -2 then?
I don't need to, I don't want to.
Oh, I get
I
that.
thought that was the answer.
Alright? So what we would then do, now there is another way of doing it, which you may have already done, but do you understand what I've done there?
Yeah.
Now what I could have done was collected this all together anyway and said, well, if that's all over 6, if I collect these together, what would it actually be?
4x.
4x.
So I expand, yeah. 4x minus 2 minus
6
5x,
plus, oh sorry.
and it would have to be plus 6, and that's where the brackets come from.
Can you put brackets on the first bracket?
I could, but I don't really want to.
Oh.
Okay? And it would end up as 4x minus 5x minus x plus 4 over 6 equals -12. And because I've got the -12 over 6, again, I can just say that this equals that. I don't have
And
to do
then
any.
you do all of it.
So now I would just do minus x plus 4 equals minus 12 and solve that. Yeah? So it's just a way of dealing with fractions that maybe you haven't done it like that before.
I feel like it's
Right, we'll carry on next time.
Oh, did you get X is 40?